Okay, so calculate the percentage error when using this syringe. You may lose marks if you do not show your working. So percentage error can be calculated by you know uh, using this formula, uh, actual error divided by uh, total volume measured multiplied by 100. So actual error is half of the smallest division, and half of the smallest division may be, if this is the volume, uh, you know if this is the smallest division on your syringe, this should be the actual error plus or minus. So this would give us 0.1 divided by total volume that has to be taken with this syringe is 2 cm cube, and multiplied by 100. So you do calculate, and that would give us a percentage error. Put 2 cm cube. This is where you have taken 2 cm cube of Benedict solution, and also you have taken 2 cm cube of the sample solution. So that is why you have divided this 0.1 by 2. Okay, so put 2 cm cube of Benedict solution into the same test tube as step 3. Shake the test tube gently to mix the contents, and read step 6 to step 9 before proceeding. You are required to observe the contents of test tube continuously while the test tube is heated for 60 seconds. Record the time taken for the first appearance of color change. If color change occurs during this 60 seconds, record the color after heating for 60 seconds. This is what you have to measure. This is dependent variable. Put this test tube into the water bath you prepared in step 1 and start timing. Record the time taken for the first appearance of color change in table 1.1. Do not stop the clock and continue heating until 60 seconds. If there is no color change after 60 seconds, record the time as more than 60 seconds. At 60 seconds, remove the test tube from the water bath, gently shake and record the color of the Benedict solution in table 1.1. So in table 1.1, you have to record the color change, and you have to record the time taken. Okay, so you have to record two things. Repeat step 3 to step 8 for each of the glucose solution you prepared in step 2. So you prepared 0.5%, 0.25%, 0.125%, and one or two more concentrations in step 2. With each of these concentrations, you should carry out this test one by one and record the time taken for each glucose sample to change its color for the first appearance of the color change. You're not required to repeat this experiment. You don't have to repeat this experiment at each concentration. Okay. Uh, Here you have to record your results. Complete the column headings and record your results in table 1.1. The first will be glucose concentration, which is in percentage. So you will write percentage after backslash. Time taken for the first appearance of color change, you will record time in seconds, and color of the Benedict at 60 seconds. So here you have 1.0%, you have 0.5%, you have 0.25%, you have 0.125%, and you have 0.06, and you can calculate what the half of it gives. I have not calculated. Okay, so 1 2 3 4 5, there must be at least 5 concentration, and you should record time taken for the first appearance of color change in the Benedict test in the water bath. You should do this with each test tube one by one and record time here, and then the color change. Here you should have the lowest time, and here you should have the highest time. If this trend is there, no matter whatever the number of seconds you get, if the trend is there that you have taken this has taken lesser number of seconds and this has taken more number of seconds, you will get 1 mark for that. So you should not write units here. Many students write units in the column. So writing units in the column that loses 1 mark, and similarly not writing unit in the heading will also uh, uh, you will lose 1 mark if you don't write this unit in the heading. Okay, so color change, the colors you can observe. What colors do you see in each test tube after 60 seconds? And avoid writing bluish, something yellowish, orangish, etc. If there is a confusion in between the two colors, like if you have a doubt in between yellow green or orange yellow, you write both the colors. Okay, describe how you will standardize the Benedict test in order to enable you to estimate the concentration of glucose in P. Standardize the Benedict's test. You can standardize Benedict test as there are 2 marks. So one way may be taken the same volume, and the other may be at same temperature. So as there are 2 marks, you should have written 2 ways you have standardized it. Repeat step 3 to 8 using solution P. Record your results for solution P. Time taken for the first appearance of color change P. You have to carry out the test as you have carried out with all these 5 concentrations. Carry out the same test with P. Means take 2 cm cube of P, 2 cm cube of P into a test tube, and also add 2 cm cube of Benedict's solution. Okay, and heat in a water bath at the same temperature, which is at 85°C. Okay, and record the time taken for the first appearance of green color change, for the first appearance of the color change here. So that would give us some number of seconds here. Color of the Benedict test at 60 seconds, so you record the color here. Estimate the concentration of glucose in P using the color of Benedict at 60 seconds recorded in table 1.1 and A4. So for example, if you have time taken for the first appearance of color change 40 seconds here, and for example you have 40 seconds here, so it means that the concentration of P is the same as that of 0.25, or whatever the number of seconds match in the column here, or otherwise number does not exactly match with it. For example, if it is 40 seconds here and this has maybe 60 seconds, and your uh, number of seconds taken for the P to change its color is, for example, maybe 53. So it means the estimated concentration will be in between 0.5 no 0.25% and 0.125%. So between 0.125% to 0.25%. So this is how you can write answer comparing this number of seconds with this column. So the condition that has the same number of seconds with this number of seconds is the same concentration of this P solution. Hope you have understood it. Then describe one improvement to allow a more accurate estimate of the concentration of glucose in P to be obtained using the color of Benedict's at 60 seconds. For this, as there is 1 mark, so you should take more range of glucose concentrations with narrower intervals. Okay. Describe how your results for the time taken for the first appearance of color change can be used to provide a more accurate estimate of the concentration of glucose in P than the one given in A4. What is A4? Describe how you your results for the time taken for the first appearance of a color change can be used to produce a more accurate estimate of the concentration of glucose in P than the one given in A4. Uh, okay, so this is actually an A4 where you have between 0.125 to 0.25. So if you have to take more accurate, you know, estimate of this concentration, so you should prepare more concentrations in between 0.125 to 0.25 and repeat this experiment. And you should use you know yes repeat this